professor, physician, epidemiology. I am Dr. Sri Banerjee. I'm Dr. Sri Banerjee, core faculty for the College of Health Sciences and Public Policy at Walden University, with a joint faculty member at Ross University School of Medicine. In this video, I'm going to be explaining some of the complexities that are connected with the flu virus. And it's really interesting because this is kind of a result of guesswork. There's a lot of guesswork involved in that the way that predictive models are created are based on the patterns that are observed within the southern hemisphere. And so having a backdrop of the occurrences within the southern hemisphere, we have an advantage in that we can predict what is going on within what will be going on within within the northern hemisphere based on that. So there's other places where this actually plays a role. For instance, understanding antigenic drift versus antigenic shift. One is rather benign, and one is not, and I'm going to explain that to you in a bit. When you have a virus that is closely related to one another, maybe closely related in a phylogenetic tree, or has antigenic properties. And so there's a difference between flu viruses, drift and shift. So antigenic drift is drift consisting of small changes in the genes. But then antigenic shift is when there's way more differences, and that actually can be dangerous enough to cause a pandemic. And so if we go look at the pandemic and other stuff like that, then we'll be able to go in and understand what are some of the areas that needed work, and what are some of the areas that we had figured out. And as it turns out, when we actually were trying to understand COVID-19, what we learned from previous pandemics, we made the same mistakes. So there's not much that was learned from previous pandemics. So anyway, the small changes result in antigenic drift, and then antigenic shift results from larger differences in the phylogenetic tree. So here's genomic sequencing, genetic characterization, and methods of flu genome sequencing. And you can use these each individually to try to determine the genetic sequencing of each influenza virus. So if you're looking at if you're looking to find out, or if you don't know what type of vaccine you'll be using, this is a good place to look at that and kind of look at the process by which everything is determined. Because when we're taking a vaccine, the less we know, the more likely there's going to be myths that are going to be perpetuated. So it's really important to go in here and not only look at this, but be able to translate this information to others who may have confusion over the effectiveness and the way that the flu vaccine is created. And I've explained to you some of this. So when does the flu season take place? Well, this flu season they actually predicted is going to be based on what they have witnessed in the southern hemisphere. This flu season is going to be especially bad. So here's the Fluzone high dose quadrivalent vaccine, Flublok quadrivalent recombinant flu vaccine, and Fluad quadrivalent adjuvanted flu vaccine. So these are all the different flu vaccines that are available. They're already available. Typically, October is a good time to take it. If you take it any earlier, there's a chance that you might have to take it again. So what are the recommendations? Well, annual flu vaccination is recommended for everyone 6 months and older. There are many different flu viruses and they are constantly changing. There are some that are egg-based, so if you have egg allergies, you might want to take the cell-based or the recombinant flu vaccine. Supply manufacturers have projected that they'll supply about 173.5 million to 183.5 million doses of flu vaccine. So that covers everything for now. I think it's important that we look at flu vaccines not only from the perspective of from knowledge, but also what is the coverage, and I'm going to show you that. So you can see the distribution of the flu vaccines throughout the country, and you can see that there's pockets within here that are missing flu vaccines. And so when you see this, then you know that there are areas that need more attention in terms of what is there in the flu vaccine, whereas others don't need that much attention. So when you see blue, and let me back up a little bit. When you're seeing light blue, that's only greater than 53%. So in some places, when it's blue, well, in Herkimer County, New York, it's over 60%. So there's actually a wide range, even in what I'm trying to say in the light blue, in that there's actually differences. And this actually, I'm looking at life expectancy, but we can make alterations. But what I'm showing you here is that even areas where there's light blue, there's more work that's needing to be done. Anyway, this wraps up the map distribution of flu vaccinations. I hope this makes sense, and I hope this gives you a little bit more insight before taking the flu vaccine, so that you can be successful in school and college, and if you're getting an education or even in your workplace, you have less loss of productivity. Thank you for listening.